Welcome, physicists. Hey, if you're doing the dry ice puck in the lab, awesome. Shout out to Miss Habert and Mr. Dubrow, as we're all using this lab for the regular physics class at ETHS. Yeah. Um, so the lab here you can watch if you want to see how a dry ice puck is made. Adds a little flavor to the lab. The part I want to look at, one thing I want to remind you of, is in the video part of this. Right. By the way, let's just watch a dry ice puck. Look at that. Frictionless almost. Pretty cool. But don't forget that you have tools like ruler here, which you can then adjust and turn to line up with the ramp. You have a protractor to measure angles, right? You can bring this down here and get the angle of the ramp. We also have stopwatch, right, which is useful. So don't forget those tools are there. The part I want to look at is calculating the velocity. So this part 4 of your data. So once you get your data, right, you're going to have your data up here in part 2, right? You're going to bring your data down here, and what we want to do is we want to find the velocity of the ice puck at 0.1 second intervals, right? So our first 0.1 second interval is from 0.05 seconds to 0.15 seconds, right? That's a 0.1 second interval. So what we're going to need to know is how far the puck went in the first 0.1 second interval. So we go back up to our data table, and we can get our distance in the first 0.1 seconds. So let's say, for example, that distance is 2, right? We're going to then come over here, and to find our velocity, it's going to be 2 divided by 0.1, or 20, right? Then we come and we look at our next interval, and let's say that we see the distance is 10 centimeters. Well, the first thing we have to think about is that it didn't go 10 centimeters in that 0.1 second. It actually went 8 centimeters, not 10, because it already had traveled 2 centimeters. So if it's at 10 now, that means it traveled 8 centimeters in that 0.1 second. So we're going to come over here. 8 divided by 0.1 is 80, right? And then we look at the next 0.1 second interval. We get the distance traveled. So let's say it ends up at 19 centimeters. That's a distance traveled of 11 centimeters, right? So now we do 11 divided by 0.1, 110 centimeters per second, and so forth. And so that's how you're going to fill out this table and then ultimately make this graph, right? And a reminder, this velocity is the average velocity of the object in that 0.1 second interval. So let us know if you have questions.